I'm going to be showing you guys a super easy way to derive the Navier elasticity equations in 3 steps, and I want you to put these steps to memory because it's going to help guide you through the derivation as you do it. The first one is CSE, Cat Study Elasticity. The second is to derive, distribute, and organize, and the third is simplified form. So what did I mean by CSE? I was referencing to 3 equations that you're going to write down when you start this derivation. The first is the constitutive equations, stress-strain equations, and the equilibrium equation. And in this case, we're going to be ignoring the z direction as well as body forces just to simplify the derivation and end up with like the x component. So the first thing that you're going to do is you're going to plug in the constitutive equations into the equilibrium equation. Then you're going to plug in the stress-strain into the equilibrium equation. The order doesn't matter too much, but I think it helps to write equilibrium last just for the sake of plugging it in. So I want you to take a second and try that. And this is what you should have gotten. Notice how this cancels right here, but it's honestly still pretty ugly. So we're going to move on to organizing it. What did I mean by derive as the first step of this? What I meant is distributing these partial derivatives into the parentheses. So take a second to do that. And from here, what we're going to do is distribute. Break it up as much as you possibly can. Distribute the lambda into these parentheses, break this apart into 2 terms, and distribute the mu into these parentheses. This is what you end up with, and from here I like to use a visual cue. I like to just remember these 2 terms, and that the first thing we're going to do is factor mu out of the terms. I mean, it's the only common factor, really, so yeah, just do that, and then notice what's left in these other terms. Do you notice a common factor? You might have noticed that the partial derivative with respect to x is a common factor between these terms. And there's one more simplification we can make. It's not the most obvious, but since lambda and mu are constants, you can go ahead and do this. And that's it. This is the Navier elasticity equation. From here, there is a way to simplify it. Not always required to know, but some professors like it. It involves the del operator and a vector field. You're probably already familiar with these, but you are definitely going to want to remember them for this. If you know the del operator, it should be pretty easy to find this. It's just the dot product. And if you know the vector field, it's also easy to find that. So I want you to take a moment and think about how you think this might get plugged into the equation we just created. This is how it plugs in for the x component, the y component, and just a general form. So that's it. Now you know. The best way to memorize it from here is to test yourself. So what you should do from here is ask yourself, can you list the 3 steps that I mentioned at the beginning of the video without looking at your notes? And then can you execute them? Try it out, see how it goes, and you'll have this memorized in no time. So good luck.